Properties of magnetic materials. There are three types of magnetic material based on the spin: diamagnetic material, paramagnetic material, and ferromagnetic material. In diamagnetic material, the magnetic moment has zero spin magnetic moment. If a diamagnetic material is placed in an external magnetic field, the electrons reorient and align perpendicular to the applied field. Their magnetic moment opposes the external magnetic field. Here we have a diamagnetic material which is placed in between two magnetic poles. All the magnetic lines of forces from the magnet are repelled away from the diamagnetic material. This effect is also known as Meissner effect. Also it is known as diamagnetism. Next we have paramagnetic materials. Here we have a few unpaired electrons in which results in a few spin magnetic moment in the absence of external magnetic field. If we place a paramagnetic material in the place in between two magnetic poles, because of the unpaired electrons, the magnetic field will be allowed or attracted. So when an external magnetic field is applied to a paramagnetic material, the magnetic moments align themselves along the field direction and the material is said to be magnetized. Ferromagnetic materials. Here we have more number of unpaired electrons results in high magnetic moment when compared with paramagnetic material. If the ferromagnetic material is placed in external field, all the lines of forces are strongly attracted towards the magnetic material. So when an electromagnetic field is applied to a paramagnetic material, the ferromagnetic material, the magnetic ones align themselves along the field direction and the material is said to be magnetized and all the magnetic lines of force attracted towards it. Comparison of dia, para, ferro. By definition, we know that is a material with which there is no permanent magnetic moment in diamagnet and has a permanent magnetic moment because of few unpaired electrons in a paramagnetic material and more number of unpaired electrons which results in enormous permanent magnetic moment in the case of ferromagnetic material. The spin dia has no spin alignment, para random alignment and ferro parallel and orderly alignment. Behavior of the magnetic material in the external field. Diamagnetic material repels the external lines of forces, paramagnetic attracted feebly, and ferromagnetic strongly attract the external magnetic lines of forces. So, since it opposes, the diamagnetic material oriented opposite to the applied magnetic field, the paramagnetic material align along the direction of the external magnetic field and ferromagnetic also same. Permeability of a diamagnetic material is very less and for paramagnetic is high. Ferromagnetic allows more number of magnetic lines of forces as permeability is very high for ferromagnetic material. That's why the relative permeability of diamagnetic material is less than 1 and for paramagnetic material greater than 1, ferromagnetic material very much greater than 1. The case of a susceptibility, how much it gets magnetized is known as susceptibility is negative for diamagnetic material because it opposes and because of the accepting property of paramagnetic material, the susceptibility of paramagnetic material is low positive and ferromagnetic material strongly attract the external lines of forces, it gets easily magnetized and susceptibility is very high positive for ferromagnetic material. The phase change transition takes place when the temperature changes. At 0 Kelvin, diamagnetic material is superconductor, which means the resistance becomes 0, conductivity is infinity. If we increase its temperature, it becomes normal conductor. Where the case of paramagnetic material, when the temperature is less than the Curie temperature, it is converted into diamagnetic. Whereas ferromagnetic material, the temperature is greater than its Curie temperature, it is converted into paramagnetic material.